Can you hear me, all of you? Kindly turn on a camera. Ritu, how are exams?
Sir, it's this Sunday.
Okay. Iha, turn on a camera. Okay. So one question was given, if I remember correct, in last class. Yes or no? Was it given or not? As home assignment? No?
Yes, sir. Yes, sir.
कितने लोगों ने सॉल्व करके भेज दिया ग्रुप पे? How many of you have solved and sent it on the group? Vihan, have you sent? Nobody has sent actually, I think. Can you try now? Please try. Spreha, have you solved this question of home assignment?
Sir, I solved it.
Please share in the group,
Okay.
or you can try now. Vihan, you're saying something? I can't hear.
No, sir, I'm talking about myself.
Okay. खुद से बातें करना. It's a
Sir,
good sign. Good sign of preparing. Yeah, this is very normal actually. Yeah, it's good. You're on the right track. See, sometimes it happens, right? When you come out of room, like suddenly you feel like, अरे कहाँ जाना था मुझे, क्या करना था? ये सब अच्छे signs हैं. That means you are doing right prep. होता है ऐसा, कितने लोगों के साथ होता है? Suddenly you forget क्या करना था, है ना? एकदम zone out हो जाता है. So that means preparation is on high gear. What are these numbers? Ask question. X by
Sir, is it C?
no. What is degree of dissociation? How much goes from 1? Okay, that we know. So this is your equation. All right. So if you write this equation, how many moles you are starting with? Starting with 4 moles of A to B. Now try to understand if it is 4 at time t equals 0 at equilibrium. You can say 4 minus. Now there are multiple options, right? One option is you say 4 minus x, x, x upon 2. Can I write like this? Because this number is 2, this number is 2, and this number is 1. Somebody can say, no, I don't want to write like this. I will write 4 minus 2y, 2y, y. It's the same thing, just variable is different. Someone can say this question is talking about degree of dissociation, so better I use alpha. 1 gives how much? Here 1 gives how much? Alpha. So 4 will give how much? 4 alpha. Alpha is defined what comes out of 1. So 1 gives alpha, 4 will give you 4 alpha. If this gives 4 alpha, how much of this will form? 4 alpha. And how much of this will form? Half of it. That is 2 alpha. There is another approach. I will prefer the third approach because it gives me answer directly, because we are interested to get degree of dissociation value. And you talk in terms of alpha make more sense, right? Is it okay? All three are correct. Try to understand for the first question, x by 4 is alpha. For the second question, 2y upon 4 is alpha. And for the third question, alpha is alpha. So eventually, you use any of the variables, it will not change your answer. Are you understanding? First, please raise your hand if you understand this logic. Raise your hand if it is clear. Everybody. Comfortable? Any doubts, please ask.
So I did not understand the x by 4 is equal to alpha, 2y by 4 is equal to alpha.
Okay. So just see. Out of 4, how much goes? You have x. So out of 1, how much will go?
X by 4.
And what is definition of alpha? How much goes out of 1? Please write.
Okay.
How
Got
much goes out of 1? That is called degree of dissociation. Unit से कितना जा रहा है? That is called alpha. Is it clear? So out of 4, 2y goes. Out of 1, how much will go? 2y divided by 4. That's why it is alpha. And the last case, out of 4, 4 alpha will go. Any problem? Any issues? कर लेंगे. अच्छा जी, मेरे को बताइए टोटल नंबर ऑफ मोल्स कितने हो रहे हैं आपके? If you add these, 4 minus 4 alpha plus 4 alpha plus 2 alpha is 4 plus 2 alpha. Check. If you divide 4 minus 4 alpha by 4 plus 2 alpha, 4 alpha by 4 plus 2 alpha, 2 alpha by 4 plus 2 alpha. What are these numbers? Asta? What is moles upon total moles?
Mole fraction.
Very good. And mole fraction into total pressure is known as? Ritu, mole fraction into total pressure is known as? Partial pressure. Okay, these are mole fraction. Total pressure, let's say we talk about P. So all these terms will become partial pressure. Now read the statement. Kp equals total pressure at equilibrium. What is total pressure at equilibrium? P. As per the question, can I say Kp itself is P? बात समझ में आ रही है आपको? As per the question, Kp itself is P. This is given in the question, right? Now, how many of you are in condition to tell value of Kp? Spriha, how will you solve Kp? What is formula of Kp for this equation? Please answer.
Kp equals to P. Sir, it was like
In terms of A to B2 pressure and A to B pressure, Spriha. Pressure of A2 whole square multiplied with?
pressure of B2 whole square.
No, 1. This is 1, no?
Oh,
Coefficient
okay.
divided by?
Um,
Reactant. Product upon reactant.
Yes, whole square, right?
AA plus BB gives CC plus DD. What is KP? Spreha. Pressure of C power C, D power D, A
Yes,
power A, B power B. So what should we write here?
2.
Whole square.
Yes,
What are these values coming up? 4 alpha upon 4 plus 2 alpha into P whole square into 2 alpha upon 4 plus 2 alpha into P divided by 4 minus 4 alpha divided by 4 plus 2 alpha into P whole square. If you see carefully, this term, this term, this term, this term get cancelled. Not only that, this 4 square will cancel out everywhere. It will become 1 minus alpha square. Do you understand? If I take 4 square out, this will become value. So if we look at the value, it becomes alpha square. This 2 alpha p and all, if you cancel, it will become alpha upon 2 plus alpha times p divided by 1 minus alpha whole square is kp. And what is kp? Kp itself is p.
So we'll get alpha is 2 by 3.
Very good. If we solve it properly, it should come 2 by 3. This cancels out. Now just simplify this whole thing. 1 minus alpha square into 2 plus alpha is cube of alpha. 1 plus alpha square minus 2 alpha into 2 plus alpha is cube of alpha. Okay. Now, PP get cancelled. So can you just open it up? 2 plus alpha plus 2 alpha square plus cube of alpha minus 4 of alpha minus 2 square of alpha is cube of alpha. Cube of alpha cancels cube of alpha. It's not a cubic equation anymore. 2 alpha square cancels 2 alpha square. 4 alpha minus alpha is 3 alpha. 3 alpha is 2. So alpha comes 2 by 3. सीधी सीधी calculation है, कुछ भी ऐसा मुश्किल नहीं. And if you look at the options, your first option itself is degree of dissociation is 2 by 3. Okay. I hope you understand this calculation also. Astha, Iha, Spreha, Vihan, Ritu, everybody is it clear?
yes, sir.
Now let's check other options. Are they right or wrong? How will you solve? So other option is total number of moles at equilibrium are 14 by 3. Just check. 4 plus. So considering the possibility of more than one option, let's try. 4 plus 2 times 2 by 3 is how much? So alpha is 2 by 3. 4 plus 2 alpha, total number of moles. What is the number coming up? 16 by 3. Check it. So this becomes wrong. At equilibrium, the number of moles of A to B are not equal to the moles of B to. A to B, how many are there? A to B are 4 minus 4 alpha. And 4 minus 4 alpha is how much? 4 minus 4 into 2 by 3. Which is how much? 4 by 3. What is 2 alpha? That is 2 into 2 by 3. How much is that? 4 by 3. Are they equal or not equal? They are equal. What the statement is telling? They are not equal, but actually they are equal. So it is wrong answer. At equilibrium, the number of moles of A to B are equal to the number of moles A2. A to B is 4 by 3. A2 is 4 into 2 by 3. That is 8 by 3. They are saying it is equal. Actually, it is not equal. So it is also wrong. So what's the answer? Is it clear? This question is a question from advanced exam, but I hope you can solve these kind of questions easily. Should not be a problem. So if your approach is clear, there will not be any problem, any trouble. Now, let's quickly revise in next 2-3 minutes what all we have done in Lee Chateliers, and then I take the last 2 parts of Lee Chateliers for inert gas addition. Okay? So फटाफट एक रिवाइज करके फिर आगे बढ़ते हैं, बिकॉज हो सकता है कि आपने रिवाइज ना किया हो, ऐसी assumption मैं ले रहा हूँ. Though you have revised, but रिवाइज किया. So what is Lee Chateliers principle? A quick review. It is applicable only at equilibrium. Applicable only at equilibrium. And of course, for reversible reaction. Okay. It is applicable only at equilibrium, of course, for reversible reaction. Now, the next point is changes introduced at equilibrium will be opposed, negated, nullified, okay, or reversed. कुछ भी use कर लो, कोई भी synonym use कर लो, और will be opposed. इतना ही ठीक है. So, for example, if a reaction is given, reactant gives product, and this is at equilibrium, and you increase reactant's amount, what will reaction do? It will try to reduce the reactant amount. How will it do? By taking the reaction forward, so that reactant is consumed. If you decrease reactant's amount, Ritu, is it clear? At equilibrium, you are reducing reactant's amount. What will reaction will try to do? Oppose you. It will try to increase. How will it go? Backward. Okay. If you want to increase, let's say, moles of reactant, that was concentration. Let's say moles, same thing will happen forward. Okay. If you increase the temperature of reaction, let's say this delta H is positive. If delta H is positive, that means endothermic reaction. That heat will be utilized to take the reaction forward. Had it been delta H negative case, it will go backward. Understand? If it is a gaseous equation, and let's say for any gaseous equation, let's say it is in 2R gives P. So in forward direction, N is decreasing. So if I increase pressure, reaction will go forward to reduce the pressure. 2 units are becoming 1 unit. That means forward movement. If you decrease the pressure, reaction will try to increase. Where will it go? Backward at equilibrium. Whatever you're doing for pressure, same is opposite of volume. So volume decrease is same as pressure increase, that means forward. And volume increase is same as pressure decrease is backward. All these things we have done in earlier classes. Okay, it's not I'm doing today. I've done it earlier. I'm just giving a quick review. Okay. So moles, concentration, pressure, volume. These things we have done or not? Kindly confirm. Anyone having any doubt, you can ask. On this
Sir,
point.
had it been that R gives 2P, then when we will increase the pressure, will the reaction still go
Backward.
forward? Backward.
Backward. R gives 2P backward.
Acha.
If you increase the pressure, reaction goes backward so that it can reduce the pressure. So other way around. Fine. Okay. Or in simple words, I'll put it like this. If you increase the pressure, reaction will move in the direction where N is less. If you decrease the pressure, reaction will move in a direction where N is more. And you understand? Summation of both the things. Right? Let's say reactant side दो तीन चीजें सारे ऐड करके देख लो. Product side सारे ऐड करके. जिस तरफ ज्यादा उस तरफ आप मूव कर सकते हो. Okay. So for example, if a question is 2NH3 gas is giving plus 3H2 gas. If you increase pressure for this reaction, where will it go? Increase pressure. Backward. Decrease pressure. Forward. Understand? Because if you increase pressure, reaction will try to utilize that pressure. Where will it utilize? By moving backward. Is it okay?
Yeah, yes.
Okay, fine. If the reaction is this, N2 gas plus 3H2 gas gives 2 ammonia, Haber's process. Pressure increase will take it forward. Pressure decrease will take it backward. Okay, simple. कर पाएंगे सारी चीजें?
So can
Any
you
problem in
explain
this?
this pressure and volume thing again?
Sure. See, what is meaning of increase of pressure? Let's say your reaction is at equilibrium, you're increasing the pressure. So what will reaction try to do? Negate, nullify, or oppose what changes you have brought in. Now tell me, if there are gaseous things and this is 2 units of R giving 1 unit of P. If pressure is increased, which side pressure's impact is more? R side, because there are 2 units. How it can reduce the pressure? By reducing that value which is having more impact. So which side reaction will proceed? Forward, so that R can reduce, P can increase. Okay. And Ritu, do you remember Q and QC and KC? Reaction quotient?
Yes, sir.
So QC is less than KC, reaction moves forward, more than KC, reaction moves backward. You can use that also to calculate the values. Now in today's class, our discussion is slightly more complicated, which is on inert gas addition. So write on the heading, inert gas addition. Spriya, is it clear?
But is this a new topic or is it under the clear?
Under this only, Lee Chatler's principle, inert gas addition. So inert gas addition, there are two things that you have to understand. One is constant pressure constant volume. So inert gas addition under constant pressure, under constant volume. Now, let's say we are taking one reaction which is N2O4 gives 2NO2. ले सकते हैं? We can take any reaction. If you're not liking it, you can take PCl5 gives PCl3 plus Cl2 or any other reaction for that matter. So if it is at constant volume, what is meaning of constant volume? Constant volume means you are having a rigid vessel which cannot expand, which cannot contract, and the volume is fixed. That is the meaning of constant volume. All right. So write down constant volume means a rigid vessel with a fixed volume. And what is inert gas? Inert gas is non-reactive in nature. आपको पता है inert gas reaction में तो part करेगी नहीं. Can you name some inert gases? Few inert gases?
Helium,
Helium,
argon,
then neon, argon, krypton,
krypton,
xenon,
xenon.
radon हो सकता है but radioactive छोड़ दो.
So
Then
xenon
nitrogen
does
is,
react, right?
yeah, but at high temperature and pressure, very high temperature and pressure. Okay, it's not normally reacting.
Yes.
Nitrogen gas is also inert. Now,
So half it.
yeah, so we can say nitrogen. Why nitrogen is not like non-reactive? The reason is, you recall the old days bulb, electric bulb, that were filled with nitrogen only. Okay, filament was kept. Now, think about the air around you. Air has oxygen, nitrogen 78%, oxygen 21%. If nitrogen is reactive, all the oxygen will react with it, and you will have NOx compound as in NO2, NO, N2, etc., which is not happening in nature, which happens only at certain temperature and pressure conditions, at high temperature conditions, right? Under certain radical reactions. Is it clear? So nitrogen is also considered as inert gas only. It will not react so easily. So sometimes they can give nitrogen also. Keep this in mind. Okay? उस पे surprise नहीं करना कि reaction करा दिया आपने. Keep it as inert only. So now, let's say a reaction is happening. Constant volume, rigid vessel, N2O4 gives 2NO2, and recall our discussion of the last class, or you can do it quickly once again. It was initially 1 moles at time t equals 0. Equilibrium, it is 1 minus alpha. This is 2 alpha. Correct? Total moles are 1 plus alpha. So mole fraction comes 1 minus alpha upon 1 plus alpha. 2 alpha upon 1 plus alpha. Partial pressure is how much? Into total pressure at equilibrium. So this P is P total at equilibrium. Fine. I'm multiplying it. Then we solve for Kp, and Kp came up to be 2 alpha divided by 1 plus alpha into P whole square. Why whole square? Spriya, is it clear now? Why whole square? Because of this 2.
Yes, sir.
divided by 1 minus alpha upon 1 plus alpha times P. This is your Kp value. Any problem in this? Any issues in this? Okay. This is the value of Kp. आप इसको simplify कर लो. Simplify करोगे. 4 alpha square Pp get cancelled, 1P will remain. 1 plus alpha will cancel, 1 plus alpha remains, and finally becomes 1 minus alpha square. Can you reach up to this? Just try. We have done it in the earlier classes. Now, we also very much know clearly that Kp depends on temperature. If volume is constant and you're trying to add inert gas, if volume is constant, a rigid vessel, you are inserting more, what do you call, more inert gas, what kind of changes do you observe? See, this V is fixed. We are adding, let's say, helium in system. So where exactly it will fit? Let's say it's n moles in. Where will it fit? Can I say it will change the mole fraction? Think. The mole fraction will be changed. Okay. So total number of moles which are, let's say 1 plus alpha will be now n moles of helium will also be added. Isn't it? Total moles will change or not? Okay. What else will change? If you have n extra moles, don't you think that pressure of helium will also raise some pressure, which is n helium RT upon volume of vessel? Think about it. Any problem? Any issues in this? So what will be the impact of it? Anybody? If you introduce n moles of helium, what will be the impact of it? Think about PV's NRT. Okay, V is constant. Okay.
Pressure increase.
So pressure will also change accordingly. अच्छा, अब एक बात बताइए मेरे को. If you're saying pressure is increasing, don't you think it will increase in proportion of total number of moles only? Yes or no?
Yes.
So what will be the change on your values? That's my question.
So reaction will go forward.
पक्का? सोच के बोलो एक बार. Constant volume case, what will be the change? Think.
Sir, I think it will go backwards because it is a rigid vessel, so it won't expand itself or something, so it will try to minimize the effect while rising the pressure or something.
Okay. Anyone else?
But I think it's going forward.
Okay. All of you please think carefully. Constant volume addition. Volume is not changing. Okay. So what you are building is extra moles. If you're adding, you are increasing in a way pressure values only. Right? Pressure of whom? Pressure of total pressure of the vessel. In that proportion only. So will it affect anything? That's my question. Just pay attention to this detail. 1 plus alpha plus n is number of moles. Earlier it was 1 plus alpha just check it. कुछ समझ में आया आपको? कितने लोगों को समझ में आ गया? क्या समझ में आया?
So because we've added more modes of.
Just look at this number, please, everyone. What I'm highlighting. And next time, what you're trying to do is you're trying to make this number as 1 minus alpha divided by 1 plus alpha plus n into some new pressure P prime. But this ratio 2 alpha divided by 1 plus alpha plus n p prime. This ratio. Talk about this ratio, please. Let's call it p prime. हाँ जी बताइए. 1 plus p prime upon 1 plus alpha plus n is how much? RT upon V. Try to understand that. And p, old wala p is what? RT. P upon 1 plus alpha is how much? RT upon V. So how many of you realize that this number which is written here is actually 1 minus alpha into RT upon V, and this number which is written here is 2 alpha into RT upon V. And in the new scenario also, this number remains 1 minus alpha RT upon V, and this number still remains 2 alpha RT upon V. ये थोड़ा सा गूढ़ बात है. It's like slightly complicated, but just pay attention, you will understand what I'm trying to convey. Is it clear? आस्था, ऋतु, नहीं समझ में आया. थोड़ा मुश्किल है, मैं बोलूंगा फिर से. इट्स नॉट, इट इज द डिफिकल्ट मोस्ट पार्ट ऑफ ली चैट क्लियर्स. सो थोड़ा टाइम लगता है, बट थोड़ा सा सोचो. फर्स्ट यू पे अटेंशन टू दिस इक्वेशन. इज दिस इक्वेशन क्लियर? PVs and RT.
So can
Vessel
you
rigid है.
explain the P part again?
Yeah, that's what I'm trying to do. So just look at this part. PVs and RT is clear. Okay. So let's say initially P total was P. This is V. Fix RT. This was number of moles 1 plus alpha. Later, you're saying P prime. Number of moles are 1 plus alpha plus n. ये helium भी जोड़ दिया मैंने यहाँ पे. RT upon V. When you solve this question and try to write the values of mole fraction, this term 1 minus alpha upon 1 plus alpha into P, 2 alpha upon 1 plus alpha into P, right? What is P upon 1 plus alpha? Just apply this. P divided by 1 plus alpha is what? RT divided by V. कर लोगे? तो ये वैल्यू तो RT, ये वैल्यू है, राइट? नेक्स्ट केस में क्या हुआ? आपने 1 प्लस अल्फा की जगह 1 प्लस अल्फा प्लस n लेके आ गए, बिकॉज आपने n मोल्स हीलियम के ऐड कर दिए. P prime is also same proportion, it has changed. Let's say this has become 1.2 units, this is also becoming 1.2. This will cancel out anyway, no? It's in proportion to the number of moles. Or can I say P is proportional to number of moles if V is constant? So how far it is matter, like how far does it matter, like P prime upon 1 plus alpha n plus n value is how much? It is same as RT upon V, which is in the previous case. Ritu, is it clear now?
So, but here, like you written this under constant volume, so how can you just assume that the pressure is also constant?
Pressure is not constant, I'm assuming. Pressure is changing. Pressure I have taken P prime. But that pressure P prime is proportional to the number of moles. I'm not taking constant. Okay. So let's say your number of moles are increasing by 10%, your pressure is also increasing by 10%. So pressure upon number of moles, they will cancel out each other. No, that 10% thing will cancel out each other. Eventually there is no change. Is it clear now? So write down the right hand side, which we are talking about right now, will end up as, इसका जो final conclusion होगा वो होगा no change. What is meaning of no change? The meaning of no change is whatever is your alpha will remain alpha. Definitely your P will improve. I'm not denying the fact that your P will not improve. Your P will improve, but your P will improve to an extent. Your total number of moles will improve. So the ratio will remain fixed. Is this point clear? Astha, is it clear now? Okay. So P prime, Spreha, is it clear? P prime, which are multiplying
Yes.
and total number of moles, both are, I'm increasing this by 2 times. So this is also increasing by 2 times. This will cancel out. So eventually there is no change in your numerical values anywhere. I hope this discussion is clear, derivation is clear. Vihan, is it okay?
Yes, sir.
Please raise your hand if it is clear. Anyone having doubt should not raise hand. If it is clear, please raise your hand. Done? चलिए अब आ जाइए कांस्टेंट प्रेशर. ट्राई योरसेल्फ. आप खुद सोचो, बताओ मेरे को क्या हो सकता है यहाँ पे. Take N2 for example. Think constant pressure and tell me what can happen. Take your time, take 2 minutes. Yes. What will be answer this time? Who can answer?
So this time would it be going forward?
Forward for which case? This case.
Constant pressure.
Constant pressure, it will go forward. Very correct. Good. Constant pressure inert gas addition impact is opposite of increase of pressure effect. Write one line. Then I'll explain. Constant pressure inert gas addition. Constant pressure inert gas addition. The direction of reaction will be opposite of increase of pressure. सेम क्वेश्चन में जाओ, प्रेशर इंक्रीज करो, उसका उल्टा कर दो, or we can say same as decrease of pressure. Understand? Now let's prove it. Why is it so? Who can answer why is it so? देखिए, N2O4 gives 2 NO2. You wrote 1 minus alpha, 2 alpha. Total number of moles, 1 plus alpha. Total number of moles, 1 plus alpha. Mole fractions are this, right? But the point here is this time pressure is constant. So when you increase N, okay, एक काम करता हूँ मैं दो पार्ट में कर लेता हूँ ताकि कंफ्यूज ना हो आप. This is old situation and this is new situation. What is N? Astha, what is N?
Moles
Of
of
inert
the
gas. Inert gas. Moles of inert gas, helium. ठीक है? This is your T equilibrium. This is T equilibrium disturbed. Can I call it disturbed? Because you are added N moles. Is that okay or not? Spriha, why I'm keeping this P constant?
because we're solving for constant P.
Very good. Because we are solving for constant pressure case, that's why we are keeping P solvent, P constant. So if that is the case, how many of you understood that this was giving you Kp value? And Kp का value please बता दीजिए. Kp आया था आपका 4 alpha square P upon 1 minus alpha square. यहाँ पे कितना हो जाएगा? Qp. Let's check Qp first. Qp is 2 alpha upon 1 plus alpha plus n into P whole square divided by 1 minus alpha upon 1 plus alpha plus n into P. यही तो करोगे? Yes or no? What will it result into? 4 alpha square P divided by 1 minus alpha will remain 1 minus alpha and this will become 1 plus alpha plus n. एक बच जाएगा, एक cancel हो जाएगा. I hope that makes sense to all of you. Just compare this value, please. 1 minus alpha square is 1 minus alpha into 1 plus alpha. This value, this value, this value, this value, everything is same. So the difference here is because of this term and this term. Can you notice this difference, everybody? How many can say QP is more than KP or less than KP?
Less.
Bolo. Less than KP. Why? Because denominator is bigger here. Denominator बड़ा हो गया, QP छोटा हो गया, तो reaction किधर जाएगा? Forward ही तो जाएगा. Now look at the reaction once again. N2O4 is becoming 2NO2. It is going forward where the number of moles of gas are increasing from 1 to 2. That is exactly same thing happening if I reduce the pressure. The reaction will go forward. So what I can say? The impact of inert gas addition at constant pressure will match up the result of pressure decrease or will be opposite to effect of pressure.
Oh, there. I think I'm not understanding that part.
This question, forward inert gas at constant pressure. Is it okay?
So I didn't.
Where N is increasing?
So I didn't understand the last little part that you were telling.
Sure. See, what I'm saying is inert gas addition at constant pressure is this. Now think same question you are reducing pressure. Same question you are reducing pressure. Where will you go? Forward. Reduction of pressure will try to increase the pressure. How will it increase the pressure? When 1 becomes 2. When more more is formed. Which side? N is increasing.
Where
Forward
are
side.
we increasing
So-
or decreasing pressure?
Yeah, if I'm decreasing pressure, it will move forward. So can I say decrease of pressure is same as inert gas addition at constant pressure? Result wise,
So why would it move forward for decrease of pressure?
this reaction. Okay, think reverse of it. If you increase the pressure, where will it go?
Okay, I actually misunderstood this part, which was why I got that wrong.
Come to this. Come to this. When you increase pressure, where will you go? Where N is less. Understand?
No, why?
When you
Because
decrease pressure, where will you go? Where N is increasing.
no, so
Or
why
N is
would
more.
we go there? I think I'm not understanding that part. Why we would go where N is less?
Okay, why will it go there? So why will it go there? Simple. Why will it go there is the reason is if you go forward, the net partial pressure of things will improve, right? Let's say, take that also. N2O4 gives 2NO2. Okay, currently, let's say its partial pressure is P1 and P2, and P2 square upon P1 is your Kp. This is the equilibrium. And let's say you make it double. You make it 2P1 and 2P2. So what is your Qp? 2P2 square upon 2P1. Can I say it is 2 times P2 square upon P1? Which is more than Kp? Why it is more than Kp? Because this is Kp. So where will reaction go? Backward. If Q is more than K, where will reaction go? Backward. So what is backward? Backward is where N is decreasing, where 2 more units are becoming 1 unit. So what is reverse of it? If this was when you increase the pressure, it's doing this backward. If you decrease the pressure, what will happen? Forward. Now is it clear?
Yes, sir.
So Spray, is it clear? Astha, Vihan, Ritu, everybody. So decrease of pressure will have exactly same effect, which is inert gas addition at constant pressure. I hope that makes clear sense of this whole discussion. Inert gas addition यही है. इस पे बेस्ड आप कोई भी क्वेश्चन सॉल्व कर लोगे किसी भी लेवल का, अब आराम से हो जाएगा. So constant volume, no change. Constant pressure, I'll simply put it, do what you will do when pressure is reduced. Or do what you will do when pressure is increased, reverse of that. Any of these three. मतलब सारी चीजें याद करोगे तो फंस जाओगे. So pick one, which is easier for you. Constant pressure inert gas addition is same result which is given by to us when pressure is reduced. One liner. ठीक है. और इजी कर दूं, प्रेशर बढ़ाने का उल्टा, वो भी कर सकते हो. It's your choice. ठीक है. Done.
So can you
Now
please
write
scroll
down.
a bit up?
Yeah. Any doubts, please ask. So we are not just mugging it up कि ऐसा होता है, रट लो, ऐसा होता है, कर लो, because normally these things are not explained in books also. If you read books also, they're not explained to that extent. But I'm giving the proper analytical reasoning why it is happening, so that you can see the things happening in front of you without mugging it up. Okay? Is that clear, everyone? Now coming to the second last subtopic of the topic, or in a way last only because the last topic is effect of temperature, which can be dealt in thermodynamics also. So in a way last subtopic of the topic or chapter, simultaneous equilibrium. Write down. Asa done? Written?
Just could you scroll up 1 minute?
Yeah, sure, sure. So as I mentioned, my aim is very simple that before you enter to 12th standard, your 11th standard should be rock solid. Very, very strong. And when I say very strong, so if you're preparing for NEET, let's say Ritu is preparing for NEET, so for her, any question of that should be done without any doubts. For all of you others, every question till advanced level you should be able to do. Then it makes sense, actually. Okay. So whatever you have studied in 11th standard, you should be able to solve all the questions till advanced level. Then it really means कि आपने कुछ सीखा है topic में. Okay. हो जाएगा, gradually हो जाएगा, because अभी आप first round you're learning, then we'll practice questions, we'll do a lot of things. अभी बहुत कुछ काम बचा हुआ है इसमें. So gradually, always at all point of time, try to 2 hours discuss with the teacher. Spriha, how much? Please note on the question first. Then we try. So question is A plus 2B give 3C, B plus D gives 2E, and 3B plus 2A gives 4F. Three reactions are at simultaneous equilibrium. Moles of CEF at equilibrium are 3, 2, and 4. Calculate equilibrium constant for all the three reactions if initial moles of A, B, and D are 8, 8, and 2 respectively. Okay. I hope the question pertains to simultaneous equilibrium. We can understand because the language is written like that. लिख ही दिया उन्होंने simultaneous. But in all questions, they will not write like this exclusively कि ऐसा ही हो रहा है. So आपको थोड़ा सोचना पड़ेगा. A plus 2B, 3C. B plus D, 2E. 3B plus 2A gives 4F. Now, please understand. They've given initial moles of A, B, and D are 8, 8, and 2. So can I assume initially A, B, and D are 8, 8, and 2? Can I write like this? And finally, at equilibrium, what is CEF? 3, 2, and 4. So that we will use. So let me solve the question in general terms and then we'll put the values. So let's say initially A is how much A? अब लिख लो यहाँ पे values. A was initially A. B was B. D was D. A was A. B was B. Can I say this is the initial situation? Everyone? A, B, D are 882. These are initial numbers. CEF is not formed. Now, next 1 minute, please don't write anything. If first reaction, this goes X unit, how much of B go? Asta.
2x.
Ritu, how much of C forms?
3.
Very good. In the second reaction, if this goes Y, Spriha, how much of this go?
Y.
And how much of E forms, Vihan?
So 2y.
In the third reaction, if this goes 3Z, how much of this go? Iha.
2Z,
And how much of F forms?
4Z.
Correct. Now remember, same compound can't have two different concentration simultaneously. You agree with this? ऐसा नहीं हो सकता ना कि एक ही concentration 3 भी है 4 भी है. ये क्या हुआ? एक ही vessel में, in the same vessel, in same vessel. क्या हो सकता है ऐसा? आप बोलो कि भाई एक ही concentration 3 मोलर भी है और 4 मोलर भी है सेम वेसल में. क्या मतलब इस बात का? No meaning of this, right? So this all happening inside one vessel. That means everybody should maintain one common value. They can't have different value. Now the question is, what is that common value? Okay. And how do we get that value?
So I didn't understand that statement.
Okay. So what I'm trying to say is, let's say you are attending this class and parallelly you are attending 3 other classes. Is it possible? ऐसा मतलब कि ऑनलाइन में सारे ऑप्शन ओपन किए हुए. So it is possible. No. Same is like that. Let's say concentration of A is overall in the equilibrium A is 2 molar for this reaction, but for this reaction A is 4 molar. ऐसा हो सकता है? Same member? नहीं. So in this case, we have written A minus X, but we have written A minus 2Z also. So we have to make it same at both the places. We can't have two different numbers. So what I'm going to do is I'm writing X here. I'm writing 2Z here. A is taken care of. This is 2X here, Y here, 3Z here. So we have to introduce everything at all the places. So you'll say minus Y for the second reaction, 3Z for third, minus 2X for fourth, 3Z for third, minus 2X for first, Y for second. Now B is taken care of. ये समझ में आया point? So you have to write same values for all the cases. And D is at just one place. Is it okay now? What we have done? So what different things were there? I have made everywhere same thing. And then look at the numbers. How much is 3x given in the question? C, E, F at equilibrium are 3, 2, and 4. So can I say 3x is given as 3, 2y is given as 2, and 4z is given as 4. So x, y, z will all come how much? 1, 1, 1. बेसिक से मैथ्स हो गई. सो क्या मेरे को आप इसका वैल्यू बोल सकते हो? ए का वैल्यू कितना आएगा? ये 8 minus 1 minus 2 is how much? 5. इधर भी 5 ही होगा. B is how much? Spreya. 8 minus 3 minus 2 minus 1 is how much? Because x, y, z all are 1. 3z is 3, 2x is 2, y is 1. What is the value? How much is B? Vihan.
2.
And D?
So D is 2
2
minus 1 is
minus
1.
1. 1. कर लेंगे? 3x is how much? This is 3, this is 2, this is 4. So you have all the values now. All the values are ready for you, right? All of you are in condition to tell me Kc ka value. What is Kc for first equation? You will say concentration of C power 3 divided by A power 1, B power 2. आता है करना? चलिए Kc1, Kc2, Kc3 तीनों सॉल्व करिए फटाफट. एंड तीनों का आंसर एक साथ Yes. Anybody who got all 3 answers? बताइए. Yeah. Spriya.
Sir, is KC 127?
27. आपने ये नीचे वाला नहीं किया?
So 27 by 20, I got that.
Yes.
And so KC2 is coming 2.
And KC3?
So KC3, it's a little large.
32 by 25 V.
How much?
32 by 25 into V. V I'm assuming total
By
volume.
25. V is given as 1 liter for this. Yeah,
Okay.
V, definitely V. So V is 1 liter. Just note down. V is 1 liter for all the things. 32 by 25. Okay. Understood? These will be your answers. How to solve? I hope you know. Just put the value E square by BD. F power 4 upon B power 3 into A power 2. Kar loge?
Sir, what is the value of C?
C is given as 3 units. No? 3C. This is 3. 3,
So
2 and
we'll
4.
be using 3 only, right?
Yeah, 3 only.
Okay.
Okay. अब एक क्वेश्चन और लिख लीजिए होम असाइनमेंट के लिए. Then we just end the session. And then if something is pending, we'll cover it separately. Next class, we are planning to start thermo in this batch. Thermodynamics. Okay. Ritu, you have done thermodynamics from starting? No.
No, I missed a few classes in between.
So we are starting from thermodynamics from starting, and then I'll go to ionic equilibrium in this batch. So thermodynamics and ionic. पूरा आप आराम से यहाँ पे कर सकते हो 9 to 10 के slot में. Monday, Tuesday, Wednesday, Friday. So homework question. And please try to submit homework this time. It's not good कि homework करते नहीं. Greetings everyone. Welcome to your lunch. Now we are going reactivity order RI, RBR, RCl, RF. Basically, if you want to break RI bond, it is easier. Why it is easier? Longer bonds can be broken easily. Please draw this kind of structure. It is self-explanatory. So which bond you can break easily? A long bond can be broken easily. Think about a long stick. You can break easily. If I give you a small stick, a little difficult. Keep this logic in head, right? Single bond can break easily, or triple bond can break easily. Single can be broken easily. ये सब पता है आपको, right? Basic fundamental of bond energy, bond strength. Okay. Bond order is more. Bond energy will be more or less. Adya. Bond order of bond is more, so energy will be more or less. More. Bond order is more means, let's say triple bond. So you need to supply more energy to break that bond. Okay. Bond order is more, bond energy is more. Bond strength will be high. But what about bond length, Yuan? It will be less. Please note down. ये सब fundamentals है bond energy के आपको पता होने चाहिए. Third, triple bond. Third bond order. Second bond order means double bond. So triple bond is a shorter bond, right? Double is a lengthier bond. Single is a much more longer bond. Is that okay? So triple, single, double. Single is more longer bond. Which bond you can break easily? Single you can break easily. Any problem in this? Any issues in this part? Comfortable is mein? Great. Now please write down the value of carbon iodine bond is 57.5 unit. Nobody's going to ask you these numbers. So you can skip the numbers also. It's up to you completely. Nobody's going to ask you these numbers. No need to remember these numbers, okay? But if you want to write, you can please, yeah. Now please write down the heading dipole moment. इसका भी एक revision में करा देता हूँ फटाफट dipole moment का भी because it will be used. Anyone still writing? Done? Dipole moment. What is dipole moment? Dipole moment is represented by term mu. इसका representation होता है mu, right? It's mu. And mu is Q multiplied by D. And Q is the charge here, plus and minus Q, placed at D angstrom. Okay, so let's say your charge is plus Q and minus Q placed at D angstrom. What will be the value of mu? Q into D. Okay, this is called dipole moment. It is a vector quantity. And vector will always have direction. इसका direction क्या होगा? कोई बताएगा मुझे? Towards minus or towards plus? Towards positive, raise your hand. Those who say towards positive. Okay, those who say towards negative, raise your hand. Arjun, where is it? Positive or negative?
Not sure.
Not sure. Okay. Chinmay?
Sir, the dipoles was negative.
Towards negative. This is the direction. Note कर लीजिए. It is towards negative. 11th में पढ़ा था, फिर से revise कर रहा हूँ. You will always get 3 to 4 chance. 4 chance on higher side, 3 chance on minimum side to revise any topic. First time you will do, second time you will do in some revision batch, third time you will again do. So every topic you will get 3 chances. You have to use at least 1 chance carefully, if not all 3. So mu is Q into D. Now unit of Q is, if you're putting in, let's say, coulombs, and D you put in, let's say, meters. So mu can be coulombs meter or coulombs centimeter, okay, as the case may be. But there's one more interesting unit of Q and D, where we write Q as electrostat unit, okay. So it is 4.8 into 10 raised to power minus 10 ESU, which is corresponding to single unit charge. And distance D, if you write it in angstrom and convert into centimeter, it is D into 10 power minus 8 centimeter. And this value after multiplication is called dBi, not Dubai, where drones are attacked. This is dBi. Okay? With that you can do calculation wise. Now please pay attention here. 4.8 into D will be the number if there is a unit charge and if the distance is D unit. Okay? So the value of the whole calculation will be 4.8 dBi. Fine? Simple? Because 4.8 तो आएगा ही आएगा और ये वाला term dBi बन जाएगा. 4.8 into D. Sorry, D will be also there. D is distance. अब मान लो क्वेश्चन आ गया आपके एग्जाम में. HCl bond length is 1.2 angstrom. Assume complete ionization, plus minus, complete plus minus. What is mu? तो आंसर क्या लिख के आओगे? What is mu? What will be your answer, please? Shravya. 4.8 into 1.2 dBi. इतना ही करना है. That's it. That's my answer. Easy? So 4.8 by default is coming. You should know this number 4.8. You cannot skip this number. And 1.2 is D in angstrom. So just write 4.8 into 1.2 dBi. That's all. Over. Done. Don't you think this unit is much more comprehensive unit? Or we can understand this unit much more easier as compared to telling about 10 power minus 18 or something like that. Because if I give you two numbers in the range of 0.00000000001 and compare with the other number 0.00000, that is more tedious job. But if I tell you 5 dBi and 6 dBi, compare, you can say 6 dBi is more. That's much more easier, right? The purpose of dBi is this only, that it is making a very small unit to a reasonably understandable unit. Is that clear? एक और question कर लो. मान लो charge आपके पास है +2 and -2. And distance is given as 2 angstrom. So what's the answer? +2 -2 charge. +2 -2, understand? Charge is broken. One is, let's say, magnesium +2 and something -2. Okay? Magnesium sulfate ले लो. Mg+2SO4-. ऐसा कुछ सोच लो. And distance is given 2 angstrom. So what should be answer? Answer will be 2 times, because this charge is double. 4.8 times 2 dBi. If it is completely dissociated, right? If it is 1, this will be 1. If it is also 1, this will also be 1. कर लोगे? ये term समझ में आ रहा है? So dBi is clear. यथार्थ नहीं clear है? Clear? Great. Any difficulty in this part? Anyone? Now I'll take some more important things here, and then we will come to dipole moment discussion in detail. Can I remove this? Okay. Now quickly answer. Out of these, so it's again a revision. Already we have done this thing.
Sir, the camera is going to be on.
Okay. I think because welcome everyone to your own channel. Welcome to this one. If I call this is A, this will please turn on your cameras.
So could you give me a few minutes? I'll turn it on in some time.
You're in school or what?
So I got really sick, so I came back home.
Okay, fine.
So-
Okay. Chinmay ji, how are you? Not audible. Mic problem. Shyam, how are you? All good?
Yes, sir. I'm fine. Just got a bit caught up today, so I had to come online.
Okay, no problem. Sorry. Yeah, chat you can remove.
I think Chinmay is right, but
No, he will, like, I think he will join Vikings sometime. Okay, chalo.
he's charging his headphones.
Okay. Okay, let's start. This was our last discussion. Please, like, I'm ignoring the yesterday's class, right? So that was this kind of extra class which came up for B1 batch. But this actual discussion, C7 and 16, if you go back, just check. Can you write ABCD for all of them? And tell the numbers. So it will be 4 for this. A, B, C, D, E, F. How many? 6 for this. Check. This is complete, like there's no symmetry.
7.
So it will be 7.
Next one is also 6.
A, B, C, D. It will be 4. Okay. Because this one I'll not give any number. This is 4 degree. 4 degree को कोई भी number नहीं देना. Because 4 degree can't put any CL, right? Now come to this one. If I call this is A, this will be B. And these will be C. And this one I'll not give any number or any alphabet. Why? Because it is 4 degree. What is 4 degree? Carbon connected with 4 carbons, right? Can you answer why I'm not writing, I'm writing A here, but not A here and here? Why? Because after A there is a B, but after C there is no B. Is it clear? So they're not on the same footing. Is it clear? Correct. Next example. A, B, C, D, E, F. So your answer will come 6. Next example, A, B, C, D. No, this is 3. And the next one is A, B, C. That is 3. This one, nothing. So I'm marking where I'm not giving anything, I'm just marking it like that, okay? It will be 3. And the last one is A, B, C. Check the symmetry. ऐसे देखो. Can you observe? So they're all at the same location actually in the structure. So your answer will be 3. All right. Is it clear, Chinmay and Shyam? Any doubts you can ask on this one? No doubts? Okay, let's proceed further. So monochloro derivatives we learned in the last class, how to write ABCD and all. That's called monochloro derivative. Now let's say you write 1 chlorobutane and 2 chlorobutane. They will be considered as positional isomer, position isomer, because the position of chlorine group is different. But the parent name is butane in both the cases. So parent name same है butane है तो आप उसमें position isomer की बात कर सकते हैं. ठीक है? Next, if you write, let's say 1 chloro 2 methyl propane and 1 chlorobutane, then the parent name is different. You call it chain isomer. I think this decision happened already, right? Any doubt in this part? So C5H12, total number of structures. Check करें how many monochloro you are getting. in C5H12. We have done this. Check your last class. C5H12 total number is how much? C5H12 total number of monochlorals. Total monochlorals are how many? No, these are three structures. Monochlorals means when I write ABCD, then I add all those numbers. So this is C5H12. What will be that number? Calculate please. Individual structure, what all alphabets you can write, and total how many structures will be out of there, right? Please do it. 8. RN, सभी को. C6H14 कितने मिले? C6H14. Check. This write ABCD for this. Then count for each case, add everything, and then get the numbers. 15. Answer is 17. Check once again. C6H14 answer is 17. Check structure by structure. First one ABC CBA. So 3. Next one ABCD. So 5. Next one ABBCCD. So 4. Next one. These three are A, then B and C. The middle one I will not give any number because of 4 degree. This one, just 2. Corner one's B and the middle one A. If you add all of them, it should come 3 plus 5, 8 plus 4, 12, 3, 15 plus 2, 17. एक बार चेक करना कौन सा आपने मिस किया है कहाँ पे लगूंगा. Shyam, did you get 17 for this question?
Yes, sir.
Chinmay, did you get 17 for this question? Okay, great. And Niharika, did you get 17 for this question?
Yes, sir.
Okay, all right. You're having cold, Niharika, right? I think yesterday also you're having cold.
Yes, sir, but it got much worse today.
Okay. Take rest, okay?
Yes, sir.
Yeah. Now, next discussion was C7H16. Total was how much? Abhi kiya aapne 2 minute pehले. Just add all the numbers. It came 39, I think, right? Just check. We have done few minutes back. 10, 17, 21, 24, 30, 33, 36, 39. Check कर लो. ठीक है, ये information समझ में आती है? So what are we drawing? What are these 39 structures representing? They are all called structural isomers. What is the meaning of structural isomer? Where the structure is different. So we can draw different structures. Under structural isomer, which one is chain isomer? Where the chain is different. For example, let's say you take any of these 4. Or let's say this structure versus this structure. This is chain isomer. If I want to draw monochloro derivatives and then check chain structure, chain isomers. So you can say if I put here, here, or here in these cases, they are all position isomers in the given structure. But if you compare these two, then chain isomer. कर लो, कोई problem यहाँ तक? Good. Now move further. Write down the heading. Functional isomers. Chain and position isomers are clear to everyone? Any problem with that? Now you can mention heading functional isomer. What do we mean by functional isomer? Functional isomer is basically when functional groups are different and the formula is same. Example के तौर पे आप ले लीजिए C2H6O. Just take this example. Okay, write down C2H6O. So C2H6O can be C2H5OH and this can be CH3OCH3. These are two probable options. C2H6O can be CH3OCH3 or C2H5OH, right? OH group is called alcohol. इसके last में suffix आता है all. So see, we have informally started IUPAC also because basic names and all we are understanding now. All is a word which is to be used. So this compound is called ethanol, right? ethanol. Similarly, methanol is CH3OH. Propanol is C3H7OH and all those. Okay, can you write structure of butanol? How will butanol look like? Aaron?
C4H9.
Any problem with this part? What is this other structure? This is called ether, right? What is ether? Ether will have oxygen, and both side valencies are available, right? Remember, it can't be hydrogen. As soon as this becomes hydrogen, it is no more ether, it is called alcohol. So how will you recognize ether versus alcohol? Ether cannot have around oxygen hydrogen. It will have some alkyl group or some group, right? So what is this compound? Is it ether? Please answer. Is this compound ether? No. It is ether. There is a pH group, oxygen and CH3. It's an ether. Okay. Is this compound ether? Yes, it is also ether. Oxygen, one side one group, one side some other group, right? They are all ethers. So not necessarily CH3 होना चाहिए, कुछ भी हो सकता है group, right? But not hydrogen. Is this compound ether? No. This is not ether because hydrogen is here. कर लोगे? So if you have oxygen, both sides you have some group which are not hydrogen, then you can call it ether. Simple. So can I say any alcohol and corresponding ether can be known as functional isomer because they both are having no unsaturations, they both are having oxygens, they both are having other things, carbon, hydrogen, right? So structures can be drawn. Just try one more question right now. C3H8O. C3H8O. Try to draw possible alcohols and possible ethers of it. C3H8O क्या है? Possible alcohol क्या होंगे और possible ethers क्या होंगे? Try करें. Done. C3H7. Okay. Can we draw other alcohols in this? Any other alcohol apart from this? What is the structure of this? Like 3 carbons in a chain? Yes. Don't worry about hydrogen. Don't worry about hydrogen. Just worry about carbon chain and OH. This is one option. Good. Yeah. Draw the second section, not the same section. Okay. Keep OH in the second. Please draw all possible alcohols and all possible ethers for this compound. Okay. So now if you draw the first compound. Yes. Yeah, I can. Any doubts? So see, number of unsaturations will be 4 minus 4, that will be 0. Okay. Can we check 4 minus 4 is 0 in this case? 3 plus 1 minus 8 minus 0 by 2. Formula याद है आपको? So 4 minus 4 is 0 unsaturation. अभी 0 unsaturation आपके पास आ रही है. That means there is no double bond, there is no triple bond, there is no ring. So you have to just draw single bonds and OH. So आपने draw किया 3 carbon straight and 1 OH. Can you do that? This compound in general name, right now, general name is called normal propanol, or we can say propanol, right? But IUPAC name is propan-1-ol. This one indicate that if I do numbering, OH is attached on position number 1. Okay. So you can call it normal propanol, or you can say propan-1-ol. When you say propan, shall I say propan-1-ol? Can I write E here also? No. Whenever you write propan, that's alkane. When I remove this E and then write OL, that makes alcohol. Right? So E cannot come. It won't become eol, right? It become propanol, right? So E आपको remove करके then now it now. What is name of this compound? If second position is in what? We can say 2-propanol or propan-2-ol. कर लोगे? A position OH, propan-1-ol. B position OH, propan-2-ol. Can you draw any other answer? C position है ही नहीं. ये A है और ये B. There are two positions only. How about ethers? So ethers will be like this: CH3O, CH2, CH3. Can you draw any other ether? Somebody can say, "Sir, मैं ऐसे बना दूँगा." But I same ही चीज़ होगी. There's no difference. Just merely tilting it to 90 degree won't make it some new compound. It is the same compound, right? Somebody make it like this. It's the same compound. Somebody can make it like this. It's the same compound. Understand? They are all same. There's no difference you are creating out of it. Now, how to write name of this? First of all, this is ether. Name of ether is, now I'm giving you informally introduction for IUPAC already. So ethers formula is alkoxy-alkane. Note down. Ethers are alkoxy-alkane. What is alkoxy? Alkoxy is the shorter group or smaller group, and alkane is the longer or main chain. Okay. अब ध्यान से सुनना मेरी बात. You have this compound. Can you figure out around oxygen? There are two groups. One side is C, one side is CC. Which is the longer one? Alkoxy is shorter, and this is longer. So which is shorter? Which is longer? If you draw any ether out of it, what kind of ether you have drawn? You have drawn this. Which is the long group? CH2, CH3 is the long group. Can I say this is the long group? So the parent name will have alkane's name as what? Ethane. Check please. Two carbons are called ethane. Are you understanding this point? So first you figure out what is a long chain and give the name ethane. And then the other part is alkoxy. Now what is this group? Can I say it is methyl group? So what shall I write? I cannot say methyloxy. It is called methoxy. Okay. So the name will become methoxyethane. Simple. Please note down. Methoxyethane is the compound. Everyone, please try to draw ethoxymethane. Can you draw ethoxymethane? Can we draw ethoxymethane? Can there exist such compound called ethoxymethane? Why it is not existing? Yes, because shorter name I am giving as a name. That's a wrong name. Is it clear? So try to understand. If you're given, let's say, 4 names, and one question is which one is not possible. You should understand what is not possible, right? Ethoxymethane has no sense because methane, 1 carbon, ethoxy, 2 carbons. How can you do that? It has to be called methoxyethane. Can you draw ethoxypropane? कैसा दिखेगा ethoxypropane? So आप propane के लिए 3 carbon बनाइए, ethoxy के लिए आगे check कर. Niharika, is it clear? This compound is called ethoxy 1, 2, 3 propane. कर लेंगे? Any difficulty? What about this compound? What should I call this? Let me try to do this. क्या बोलना चाहिए इसको? Arab. Where is the main chain? This is the main chain. Long chain is this.
Methoxypropane.
Okay. And what is the name of this compound? Arab. That is also methoxypropane.
Yeah.
How will you differentiate them? This is position 1 methoxy and this is position 2 methoxy. So please write down
Methoxy-2 propane.
2 methoxypropane. 2 methoxypropane. That means second position methoxy is involved. And this is a propane. But this one is 1 methoxypropane. Yes. So if OC is hanging here in the middle at this place, it's position number 2. So it's a 2 methoxy. How will you identify 2 methoxypropane? Is it clear? Here it is position number 1, so I'll call it 1 methoxypropane. Please write down both the names. And online people, is it clear? Raise your hand if it is fine. Sham, Chinmay, and Niharika. Is it clear? Great. So can we do such things? 2 methoxypropane and 1 methoxypropane, you can draw these structures without much trouble.
But how do you use power when you use something?
In which case? As in?
Like, is it 2 comma?
No, 2-methoxypropane. Second position methoxypropane. Where do you have dimethanol? We come. What are the names of this? Next, write down C4H10O. C4H10O, try to draw possible alcohols and possible ethers out of it. Correct, try correct. C4H10O, possible alcohols and possible ethers. जितने भी बना सकते हो बनाओ. Possible alcohols and possible ethers. Possible alcohols and possible ethers. Number of unsaturations will be 4 plus 1 minus 4 plus 1 minus 10 minus 0 by 2. That is 5 minus 5, that is 0. 5 unsaturations को कैसे take care करो? Sorry, 0 unsaturation को कैसे take care करो? We can have 4 carbons in a straight chain. Now write ABCD on that and draw a structure. 3 carbon in a straight with 1 branch. Write ABCD on that. Then write merge. Okay. Then for ether part, 1 carbon one side, oxygen 3 carbon other side. Can be a straight chain. That straight chain can be branch chain also. The next will be 2 carbon this side, 2 carbon other side. सारे structure बना लीजिए. Good. First सही है, second ठीक है, ये भी ठीक है. But now I'm just trying to figure out. This is 4 members in a straight, right? Can there be 3 members straight, 1 carbon branch? That will also be C4H10. This question. No. This is not same as this.
So, how many branch chains?
You can give 1 carbon, yes. Now you can put OH here, or you can put OH on terminal. Because these 3 are one type, and this one is another type. So draw structures.
Can I like hang like so 3 carbons OH. This carbon can I put below here?
This is correct. Good. This is correct. This is correct. This is correct. Draw one more. No, you draw all 1, 2, 3 carbons, and then put OH on terminal ones. Because if this is A, these 3 are B.
Right.
So you have put already on A position. Now you can put of any of the B positions, right? Correct. Solve kariye, solve kariye. So to draw any structure, you need to understand how do we write the skeleton. Once you can draw that skeleton, you can get the answers. Hello, sir. बस एक क्लास में बताइए. अल्कोहल्स कितने मिल रहे हैं? 4 अल्कोहल्स मिल रहे हैं सभी को. Good. 1, 3, 2, 2.
These are the same. These 4 are. This is same as this.
अच्छा ठीक है, ये 4 है ना. So 1, 3, 2, 2. 3 को आपने bifurcate कर दिया. ये क्या किया? How do you write IPAC name of the first?
Greetings everyone, welcome to your channel Mishra Genius Labs. We are doing PYQs on equilibrium, which is chemical and ionic equilibrium. Very important topic of grade 11th and very important topic for JEE examination. So let's see question number 25 on your screen. Which of the following solution will have pH close to 1? 4 options given है आपको. First is HCl and NaOH combination. पहले check कर लो कि broadly क्या दिया. इन क्वेश्चन को सॉल्व करने के लिए आपको मिली इक्विवेलेंट कॉन्सेप्ट आना चाहिए. सो फर्स्ट केस 100 into 1 by 10 is 10 MEQs. n फैक्टर 1 है दोनों तरफ, तो n फैक्टर में 1 मल्टीप्लाई करूंगा. 100 ml m by 10 NaOH. So both are equal, and this will give you NaCl, which is 7 pH. Second case, 5.5, 4.5, remaining is 1.5, total volume is, remaining is 1.0, total volume is how much? 100 ml. So 1 divided by 100, इस तरीके का data बन जाएगा. So you can check the options for this part also. So can I say for this part, it will not match with 1. C option, 10, 1 by 10 is 1 millimoles, the other is 9. NaOH is dominant, it will be towards NaOH, so it is more than 7 of course. Last option, 75 into 1 by 5 is 5, 15, and 25 into 5 into 1 by 5 is 5. So this is 5 and the other was 15. 15 MEQs of HCl, 5 of this, remaining is 10. 10 MEQs HCl के मिल गए, total volume हो गया 75 plus 25. कर लेंगे, यानी कि 100 ml. So 10 divided by 100 से मुझे क्या मिलेगा? Normality of H plus, which is 0.1. तो pH सॉल्व करोगे तो exact value आएगी 1. एक पॉइंट यहाँ पे नोट कर लीजिए, अगर आपको नॉर्मेलिटी गिवन है तो वो डेटा सीधे आप रख सकते हो H प्लस के लिए, OH माइनस के लिए. नो नीड टू मल्टीप्लाई एनी फैक्टर, दैट डेटा इटसेल्फ कैन बी एन आंसर. फॉर एग्जांपल, इफ यू आर गिवन 0.1 नॉर्मल H2SO4, your answer for pH is 1. But the same question is 0.1 molar H2SO4, you have to get normality and then get the numbers. So I hope this question is clear. Answer will be D for this question. 26th question on your screen. The degree of dissociation of water at 25 degrees Celsius is given as 1.9 into 10 power minus 7 percentage, and the density is given as 1 gram per ml or 1 gram per cubic centimeter. Ionic constant of water is required. So if you know what is density of water, 1 gram per ml, we can say 1000 gram for 1000 ml, which is 1 liter. We'll divide it by 18 gram per mole, we get 55.55 moles per liter. And for that 55.55 minus 55.55 alpha will give you 55.55 alpha, and OH minus also the same number. Ionic constant of water is multiplication of H plus and OH minus values, right? Now alpha is given as 1.9 into 10 raised to the power minus 7 percentage, that is 1.9 into 10 power minus 9. तो वैल्यू आप अगर रख देते हो सिस्टम में, सॉल्व कर लेते हो सारी चीजें, तो निकल के आपका आंसर क्या आएगा? 10 पावर माइनस 14 आ जाएगा. ठीक है, कर सकते हैं. Question 27 देखते हैं. Which of the following is more acidic in aqueous solution? FeCl3, BCl2, NiCl3, NiCl2 and AlCl3. तो इसमें एसिडिक निकालने के लिए आपको क्या करना पड़ेगा? आपको रिएक्शंस देखनी. If you use AlCl3, right, with water, what it can form? AlOH whole thrice, and can it form formation of HCl, right? So yes, it can give you HCl. So answer will be AlCl3 because बाकी सारे basic nature बन रहे हैं. तो ऑप्शन आप मार्क करोगे C option. Question 28. The following acids have been arranged in the order of decreasing strength: ClOH, BrOH, IOH. कभी भी किसी एसिड के लिए आपको चेक करना है तो आप पहले H रिमूव करते हो और देखते हो O माइनस जो आ रहा है सभी पे वो कौन पुल कर रहा है. So in one case Cl is pulling, in one case bromine is pulling, in one case iodine is pulling. So which is the best case scenario? Answer will be chlorine. Okay, so you can mark option as A option. Question 29 on your screen. The pH of 0.1 molar solution of the following salt increases with the order. देखो pH कब increase करेगा? pH तब increase करेगा जब आपके पास basic nature बढ़ता जाए, है ना, acidic nature कम होता जाए. तो क्या A और C option हो सकते हैं? बिल्कुल नहीं. A और C तो बिल्कुल option नहीं हो सकते. अब आपको doubt हो सकता है B और D में. तो B और D में एक बार check करो क्या क्या लिखा हुआ है. Check B option. HCl, then NH4Cl, and then NaCl, and then NaCN. I think that makes sense because gradually basic nature बढ़ता जा रहा है, right? So answer is B. We can mark the answer for this question as B. Question 30. 3x plus y gives x3y. The amount of x3y will affect the equilibrium. At equilibrium is affected by. So what's the answer? Temperature only, pressure only, and all those things are mentioned. x3y का amount change करना है. अगर आप pressure बढ़ाओगे तो reaction forward जाएगी तो बढ़ सकता है. अगर आप टेम्परेचर चेंज करोगे तो भी हो सकता है, राइट. कैटलिस्ट से क्या मुझे इक्विलिब्रियम का अमाउंट चेंज होती मिलेगी? कभी नहीं मिलेगी, तो वो आपको आंसर में नहीं मार्क करना. बाकी सारी चीज़ आप मार्क कर सकते हैं. तो आंसर हो जाएगा इसका ए ऑप्शन. Another question on the screen, question 31. For the reversible equation, at this temperature, the value of Kp is given as this. When partial pressure is measured in atmosphere, the corresponding value of Kc with concentration in mole per liter is how much? Kp is Kc RT power delta n. Delta of this equation is -2. तो R की वैल्यू रखो 0.082 और T की वैल्यू रखो 500 सेल्सियस है तो 773 केल्विन हो जाएगी. Kp is Kc RT power delta n. Kc is Kp upon RT power delta n, which is RT power minus delta n, ऊपर आ जाएगा. तो कौन सा ऑप्शन इस फॉर्मूले में सेट होता है? चेक ऑप्शन नंबर बी. कर सकते हैं. The value of Kc is what? This number, delta N is -2. Option number B we can mark. Question 32. The two reactant A and B are mixed and give products AC and D. The reaction quotient Q at the initial stage, ये 2000 की screening में आया हुआ question है, is, so options are 0, decrease with time, independent with time, increase with time. Okay. So reactant C और B mix किया आपने, C और D. The reaction quotient Q at the initial stage of the reaction. Initial stage में क्या होगा? Q का value काफी छोटा होगा, तो reaction किधर जाएगी? Forward direction में. तो Q क्या होगा? बढ़ता जाएगा time के साथ, right? So Q will try to approach K. If you are towards the end of the reaction, then Q will be very high value. It will start coming back. So answer you can mark is option number D. Thanks so much for liking, subscribing and sharing. Keep share with your friends and other students also. Thank you. In discussion about dipole moment, and it has revised all the concept of dipole moment. Now with dipole moment, there is another very important concept which you have done in chemical bonding, is called covalent and ionic character, and we should also review that because we are doing dipole moment, so that will be the completion of whole topic. Okay, so we'll just take one moment and do that. Anyone still writing this? Can I remove? Niharika, Chinmay, Arjun. Okay, now please see. HCl bond length is given as D angstrom. Assume X percentage ionic character. Find out mu. अब आप X की वैल्यू D की वैल्यू रखते रहना और आंसर निकाल लेना. Any type of question you can solve. I'm just doing a general question. So what's my answer in this case? If this is the question given, HCl and assume X% ionic character. So remember, if it is 100% ionic character, this will break as plus and minus completely. If it will break completely plus and minus, what will be your values? Yes, please. If it will break completely plus and minus, can I say your answer would have been 4.8 into D divided? Say yes or no. For 100%, this would have been answer. Shravya, is it clear? 100%, this would have been answer because this will break completely. 4.8 into distance. Distance should be in angstrom. This is my answer. But since it is X%, let's say 25%, 30%, 40, कोई भी question solve कर सकते हो. So what should be the value now for this case? 4.8 into D into X divided by 100. तो ये mu का value हो गया. Solve. Answer. Easy. न्यूमेरिकल क्वेश्चन के फॉर्म में देख लो. कैलकुलेट आयनिक कैरेक्टर ऑफ HCl where mu observed is given as distance of HCl. दे दो पहले. Distance of HCl is let's say 1.2 angstrom and mu observed is given as 4.8 divide. तो बताइए आंसर क्या होगा? Calculate percentage ionic character of HCl. Mu observed is 4.8 divide. What is the value of ionic character? Had it been 100%, your answer would have been 4.8 into 1.2. ये 100% का benchmark है. This is benchmark of 100%. Is it clear or not? Shravya, Sanjana. 4.8, 1.2. Didi, is it clear? This is benchmark of 100%. Question is find out percentage ionic character. What is the current value? Current value is 4.8 divide. So if I put 4.8 divide, what is the percentage? This is ionic character. Third loge. What is actual value? What should be the value? What is actual value? And then you can solve. Is that okay? If somebody asks what is percentage covalent character, 100 minus percentage ionic character is called covalent character. Is it clear? Yeah, sure. 4.8 into 1.2 is the benchmark for 100% ionic character, but our value is just 4.8. Okay, just to make the data simple, I have given 4.8. They can give 2.4 also. So what is the percentage? This is for 100, so this is for how much? This upon bigger number into 100. It's like 4 pens are 100, 2 pens are how much? 50%. This is 4 pens, this is 2 pens into 100, 50%. Is that okay? Any problem in this part? Any issues, anyone? Any difficulty in this part? Clear hai pura? All right. So now we'll come back to the discussion and understand dipole moment. So what is dipole moment? We understand properly now. Any compound which is having dipole moment, non-zero dipole moment, will be polar. Okay. Any polar compound, basically let's say HCl. Polar means what? You have this kind of polarities developed. If you have this HCl, you bring another HCl, these will interact with each other. When they interact with each other, it's called dipole-dipole interaction. This is a dipole. Di means two, pole means plus and minus charges. So if you have one HCl, you have another HCl, can we say these molecules can interact with each other? And this interaction is named as dipole-dipole interaction. Okay. There can be multiple type of interactions. It can be ion interaction or interionic interaction, ion-dipole interaction, dipole-dipole interaction, dipole-induced dipole interaction, induced dipole interaction. Again, last year chemical bonding. Okay. So when you talk about dipole-dipole interaction, H bonding, hydrogen bonding is also an example under that. With a specific fluorine, oxygen and nitrogen forming this kind of dipole-dipole interaction. Now, if dipole-dipole interaction will happen, do you think that boiling point will be higher because of strong interaction will happen? Strong interaction will make boiling point high, right? If you have big size molecules, their molecular weight will be high. That's another link for boiling point. So if your dipole moment is high, if your size of molecule is high, okay, or if dipole moment is high, if symmetry in the structure is less, in all such cases, boiling point will shoot up. Why will it shoot up? Because boiling is a process where you are converting that liquid into vapor. You are overcoming the interactions. To overcome interaction, you have to supply energy, right? Shyam, is it clear? So if forces are strong, you have to supply more energy. If forces are strong, you have to increase boiling point more. Arav, is it clear? Akshay, are you understanding this point? So I'm just writing. Let's say if a question comes in exam, CH3Cl and CH2Cl2, किसका boiling point ज़्यादा है? तो क्या बोलोगे? अभी इसमें आपको कुछ भी नहीं check करना है. Just see, this is having high molecular weight, big size. This is higher, right? But if a question comes, let's say CH2Cl2 and CH2Br2, अब किसका ज़्यादा है? So you should know what is CCl and what is C we are doing here. Understand? The value of dipole moment you have to check. Broadly speaking, you should think that this will have higher dipole moment because of, higher boiling point because of big size, big molecular weight, right? Bromine is higher. But if you compare the cases of, let's say, 4 carbon in a straight and 4 carbon in branch, which will have high boiling point? First one or the second one? First one will have high boiling point. Because second one is having more symmetry. Symmetry is branching. Branching will reduce dipole moment. Are you understanding? So branching, symmetry less, boiling point high. Symmetry more, boiling point less. Symmetry more, dipole moment is less. These things are interrelated. Okay, just note down this part.
Symmetry and branching, the same thing.
Yeah, symmetry I'm talking in terms of branching, not in terms of ABC. Okay, Arjun? Yeah.
Yes.
Kindly note down this part. Now, if you see CCl4, it is a non-zero thing. CCl, then you have to see which one is higher, which one is less. Is that okay? ये point समझ में आ रहा है? So, अगर molecular weight ज़्यादा है दूसरे का तो of course that will be higher in boiling point. But if same molecular weight you are comparing, see the symmetry. See the dipole moment and then decide. I hope that whole discussion makes sense. अभी हम लोग रिएक्शन तक नहीं पहुंचे, थोड़ी दूर है रिएक्शंस. We are still doing physical properties, dipole moment, all those things, right? So we have to reach reactions. Then आपको actual reactions भी करने को मिलेंगे इसमें. Done. Can I move further? So this is clear. More branches. Look at this part. More branches, lesser boiling point. Note कर लीजिए. Big size, high molecular weight, high boiling point. ये भी note कर लीजिए. These are some thumb rules, some basic rules. Okay? Any issues with this? Tired? Too much information? Too much information. Okay. Okay, let's practice few questions then, because I can see faces. Further theory will be more devastating, no? इसमें और भी कराते जा रहे हैं. So we'll do some questions and then we'll see. So let's see, can we solve few questions or not? So let's check that. Compare the boiling point of neopentane, isopentane and normal pentane in decreasing order. In decreasing order. Question number 2. Find out number of unsaturation in cubane. Cubane का स्ट्रक्चर होता है ये. क्यूब जैसा स्ट्रक्चर होता है. And everywhere carbon is placed. These are carbons. आज ही किया है number of unsaturation, so I can ask this question. Count 1 degree, 2 degree, 3 degree, 4 degree carbons and 1 degree, 2 degree, 3 degree hydrogens. Remember, 4 degree hydrogen is not possible because if 4 carbon is connected with 4 carbon, there is no space for hydrogen. In this compound, तीन क्वेश्चन दे रहा हूं, ज्यादा नहीं दे रहा हूं. एवरीवन प्लीज सॉल्व इट. टेक इट एज अ स्मॉल क्विज ऑफ, कितना टाइम चाहिए इसके लिए? 5 मिनट्स काफी होगा. 5 to 7 मिनट ले लो. 7 minute quiz. Do it properly on a separate sheet. On a separate sheet, write your name. So question number 1, boiling point of normal iso and neo. So highest will be decreasing order, so you should write normal pentane as 1, and let's say this is 2 and this is 3. So answer should be 1 is more than 2 is more than 3. How many got it correct? Check your answers. Number of unsaturation in cubane should come 5. कितने लोगों का 5 आ रहा है? 5 आ रहा है? Very good. Count 1 degree, 2 degree, 3 degree, 4 degree carbon. 1 degree, 1 degree, 1 degree, 1 degree, 1 degree, 1 degree. So 1 degree कितने हो गए? 6. 2 degree कितने हैं भाई? ये वाला कितना है? 2 degree और that's it. 3 degree, 1 and 2. And this one is 4 degree. Total carbons कितने हैं? Check कर लो एक बार. 6 to 8 to 10. 4, 7, 10. 1 डिग्री हाइड्रोजन्स कितने होंगे? सॉरी 4 डिग्री पे हाइड्रोजन्स कितने होंगे? कुछ भी नहीं, तो पूछा ही नहीं है. 1 डिग्री में कितने होंगे? 6 into 3, 18. 2 डिग्री, yes, into 2. And 3 degree, 2 into 1, 2. So formula of compound is what? C10H22. Now check. Greetings everyone. Welcome to your own channel, Anuj Mishra JEE NEET Labs. We are doing PYQs on solid state and surface chemistry. Welcome you all on this channel once again. Let's see certain questions on PYQs. Question number 10 on your screen. Total volume of atoms present in face-centered cubic unit cell of a metal is what? Okay. आपसे पूछा गया वॉल्यूम ऑफ एटम प्रेजेंट इन FCC यूनिट्स कितना हो? अब बताओ किसी भी एटम का जो शेप हम एज्यूम करते हैं वो स्फेरिकल एज्यूम करते हैं और एक स्फीयर का वॉल्यूम क्या होता है 4/3 पाई आर क्यूब, राइट? अब आपके पास FCC अरेंजमेंट है, फेस सेंटर्ड क्यूबिक है, यानी फेस सेंटर और कॉर्नर पे एटम। फेस सेंटर की प्रोजेक्शन कितनी होगी 12, तो आप फेसेस कितने होंगे 6 फेसेस हैं आपके पास, सो 6 into हाफ यानी कि 3 और कॉर्नर्स 8 हो गए, 8 into 1/10 यानी कि 1। नेट वैल्यू कितनी हो गई 4। सो नेट प्रोजेक्शन FCC की 4 है और एक एटम का वॉल्यूम आपको पता है 4/3 पाई आर क्यूब, तो टोटल वैल्यू कितनी हो जाएगी 4 मल्टीप्लाइड बाई 4/3 पाई आर क्यूब। आंसर आएगा 16/3 पाई आर क्यूब। अभी आप समझ पा रहे हो पूरा क्वेश्चन डिटेल में, आंसर विल बी बी। सेम क्वेश्चन अगर आपके लिए सिंपल क्यूबिक में आ जाए तो आंसर होगा 4/3 पाई आर क्यूब, और अगर यही क्वेश्चन BCC में पूछा जाए तो आंसर क्या होगा 2 प्रोजेक्ट